Welcome back. We have this Cramer's rule that we are trying to use, trying to find I1. We have computed the determinant, and we have the result here. I have the numerator is 693, the denominator determinant is 443. I'm rewriting it here. I can say current, because in this case the current through the 3 ohm resistor is this I1. I can say I3 ohm, I can say it prime. This prime, I mean that this is the one produced by 9 volts. It is not total current in the 3 ohm, but the current in the 3 ohm produced by this 9 volts acting alone. I'm indicating this direction because direction is towards here. Because we are still going to add the production of the 3 sources together. If some is producing opposite direction, I will have to subtract. If they are working the same direction, so that's why I'm indicating direction. That the direction is towards the right. So, having done that, let me proceed. I will need this figure later on. But let me clean this and let me proceed to the next source acting alone. So let's now say that 7 volts is acting alone. 7 volts acting alone. You have to redraw another diagram for that. So, but me, I will just adjust my own. I will introduce the 7 ohm. I will introduce the 7 volts. I think, is it up that is plus or minus? Which one? Where is that my paper?
Minus on top.
Okay, minus on top, plus below 7 volts. Then I will have to remove 9 volts. We don't want 9 volts to act. I will remove it and bridge it. I will still let 5 ampere remain removed because we don't want it to act. I will open it. Now, so this is my next circuit. Let me still call this one I1, I2, I3. Now, if that is the case, let me use mesh analysis again. That's why I first treated mesh analysis. Mesh analysis is handy, and you can use it in other methods. Now, so if I write mesh for this first mesh, the source there is 0. I will have 3I1 plus 4I1 minus I2, because I1 is dropping down, I2 is going up. So from here, 0 equals 7I1 minus 4I2, I can say plus 0I3, because I3 is not there. You should always remember to label your equation. You can call that one equation 1. Sorry, in the previous one I didn't label. You can call it equation 1. And then the next is that for this other one, 0 equals 5 into I2 is dropping current. Sorry, we are in the third loop. This should be I3. I3 is the original current there. So for this one, this will be I3. I3 is going like that. I2 is going like that. I3 minus I2 plus I3. This one ohm is taking only I3. So from here I can say that 0 equals minus 5I2 plus 6I3. I can say plus 0I1 because I1 is not there. I can move to the next one and say that in this mesh analysis I have 7 volts. The direction of the EMF is in line with the chosen direction, so it will be plus 7 equals I have 2I2 plus 6I2 because only I2 is going through them, plus 4I2 minus I1 because I2 is going up, I1 is going contrary. That's why it's going to be minus, and then plus 5I2 minus I3 because I2 is dropping current in this direction, but I3 is going like that. So and I2 is the owner here. So from here I can write that 7 equals I have minus 4I1 for I2 2 plus 6 8 plus 4, 12 plus 5, 17. That's plus 17 I2, and then minus 5 I3. So I can go to the same matrix. I can say the first one is what? 0, 7 minus 4, 0. The next one is what? 0, 0 minus 5, 6. The next one, the last one is what? 7 minus 4, 17, and minus 5. So this will be like that, equals in matrix form, multiplied by I1, I2, I3. We can find the result. The result is going to be such that I1 is going to be equal to determinant over determinant. This will be 7. My calculator of determinant will be calculating it and declare the result for me soonest. This will be minus 5. This will be 6. This will be minus 4. This will be 17. That will be minus 5. But on top here, I'm going to have 0, 0, 7. I'm going to have minus 4, minus 5, 17, 0, 6, minus 5. So definitely, you are going to have 4, 4, 3. Like we had the other time. The below is going to be the same because it seems it's the same as the previous one. Oh, no. It won't be. Which one did you get?
Minus 443.
Yeah. Minus 443. Thank you very much. And one on top. So I can now say I3 ohm prime equals. So what do you have? Can you pause? No, don't pause, don't worry. So that we don't run to the same problem. Our calculator is still calculating it. It's a man that's calculating for you, for us. So it's one of your colleagues that's calculating for us. So when we make mistake together. When we fumble together. I don't bring finished solution to class. We have to generate it together. We have to cook it together. So and you should be cooking it as you are watching the video. You should also be practicing it, the punching calculator. If you see we have made any mistake, please correct us. What is it? Minus 168. Yes, so which means it's going to be plus at the end of the day. 168 over 443. 168 over 443. 443. It is still saying that direction because we got positive. That means that is the direction. Now we have gotten, so we keep that too. I put prime, meaning that that's the contribution of the second source. When I put prime, that's the contribution of the first source. Prime, that's the contribution of the second source. We're going to combine them together later. We must know the direction. When the direction is opposite, we have to subtract. We are not adding. So if it is plus 2, plus 3, minus 1, we know what to do. So that's the end of that. Maybe we should pause here. Maybe we should end the video here and we'll continue in video 15.